Welcome to Lecture 6 of Beginner's Guide to Understanding Chemistry. This lecture will be on bonding. I'm excited about this lecture because it's the first time we actually start to put a visual picture together of what we've been talking about these past 5 lectures. Bonding. Elements bond together so they can share, donate, or accept electrons, and thereby feel more like noble gases by completing each other's octets. There are 3 kinds of chemical bonds. The first kind is called an ionic bond. This is a bond between a metal and a nonmetal. Remember, go back in your notes, how do we distinguish a metal from a nonmetal? The second type is called a covalent bond. These are bonds between 2 nonmetals. These are probably the most important types of bonds when we want to understand the chemistry of psychedelic drugs. So there are 2 types of covalent bonds. A is called the nonpolar covalent bond, and B is called the polar covalent bond. We'll discuss these later during this lecture. The third type of bond is called a metallic bond. These are not important for understanding psychedelics, so we won't talk about these. In the previous slide, we said the first type of chemical bond is called the ionic bond. When a nonmetal bonds with a metal, the metal basically gives its electrons to the nonmetal. This is due to the differences in electronegativity. Basically, a nonmetal is much more electronegative than a metal. Go over the electronegativity trends that we looked at a few lectures ago, if you don't know why. By doing this, the metal becomes a cation. This is defined as a positively charged atom, and the nonmetal becomes an anion, which is a negatively charged atom. When Na, a metal, bonds with Cl, a nonmetal, the Na transfers one of its electrons completely to the chlorine, forming Na plus Cl minus, sodium chloride or table salt, abbreviated as NaCl. The Na plus is the cation, and the Cl minus is the anion. Let's look at this reaction. Finally, we get to make a picture of what's going on. We talked about in the previous lecture how we can figure out the number of valence electrons in an atom. Go over those lecture slides if you don't remember, but sodium has 1 valence electron. On the other hand, chlorine, being in group 7A, has 7 valence electrons. We said when these 2 things react, the sodium is going to donate its 1 electron to chlorine, the more electronegative element or the nonmetal. So it uses its electron, transfers it to the empty spot in the chlorine, which gives us Na plus. Notice how the sodium has no electrons. It has donated its electron, becoming positively charged. The chlorine taking on an additional electron is going to become negatively charged, because it is accepting an electron, which is a unit of negative charge. This is often abbreviated as NaCl, or sodium chloride. So you should work through the following problems. The first problem, show the bonding between potassium and bromine. This will follow the same exact protocol or visual description as the reaction from the previous slide. So kind of just work through that problem to make sure you understand how the electron transfer is occurring and which atom becomes positive and which one becomes negative. This one is slightly different, but I trust that you guys can work through it. The reason this problem is different is it asks you to show the bonding between magnesium and oxygen. Magnesium is a group 2A element, which means it has a positive 2 charge, and oxygen has a negative 2 charge. So I will tell you that when you do this reaction, you should be transferring 2 electrons from the magnesium to the oxygen. And now we get to the covalent bond. We will first talk about polar covalent bonds. When 2 nonmetals bond together, they form a covalent bond. When hydrogen, a nonmetal, bonds with Cl, a nonmetal, they very unevenly share the electrons because chlorine is much more electronegative than hydrogen. This is different from the ionic bond because one element doesn't donate and one element doesn't accept the electron. They very unevenly share the electrons. When hydrogen, with its one valence electron, combines with chlorine, with its 7 valence electrons, we talked about before how the hydrogen sort of donates its one electron. In this case, it'll be a very uneven sharing of electrons, not quite a donation as with the ionic bond. This will give us hydrogen bonded with chlorine. The situation here is we can write it out like this. A lot of the times when there is two electrons shared between two different elements, you can draw the two electrons as a line denoted here. What this is really trying to illustrate is that we have this very uneven sharing electrons. There's this idea that arises when you have a very uneven sharing electrons, but not a donation of electrons, as in the covalent bond. Because the hydrogen most of the time is donating its electron, it's partially positively charged. This is the Greek symbol delta, delta positive. The chlorine accepting the electron very unevenly is denoted as delta negative. The analogy here is like a tug of war between a 300-pound football player and a 100-pound person. The 300-pound football player is going to be able to pull the rope much more strongly towards themselves than somebody that weighs 100 pounds. Although they're sharing the rope, the 300-pound football player is able to pull the rope towards them with a greater force because the person on the other side is 100 pounds. In this analogy, the chlorine is the 300-pound football player and the hydrogen is the 100-pound person in the tug of war. And the bond represents the rope, so to speak. There's an idea here. There's another way that we can represent this. It's called representing it with an arrow called a dipole moment. This is showing that the electrons are really traveling from the hydrogen to the chlorine and staying around the chlorine much longer than they would stay around the hydrogen. But because it's not completely donating its electron to the chlorine, it's partially positively charged. The chlorine taking on the electron in a very uneven manner is partially negatively charged. And as usual, you should work through the following practice problems to see that you understand the material. Using the last slide as a template, show how hydrogen and fluorine bond together. Show the movement of electrons, the partial charges, and the dipole moment arrow. Number 2, using the last slide as a template, show how hydrogen and bromine bond together. Show the movement of electrons, the partial charges, and the dipole moment arrow. We covered a lot in this lecture, so I hope you guys are doing okay. If you are not, just please let me know. Anything I can do to help your understanding would be greatly appreciated.